Okay. So we will revise the chapter 4, that is the application of the integrals. Okay. So this is the vector calculus, and we will revise the chapter 4, that is the application of the integrals. Okay. So first we will see what do we mean by curl of a vector. Okay. So that a bar is equal to mi bar plus nj bar plus pk bar is a vector field. Then the curl of a bar del cross a bar is this. Okay. So we'll solve some examples of this. Suppose a bar is equal to, we'll take a problem from the exercise. Okay. Suppose a bar is equal to x plus y minus z I bar plus twice x minus y plus 3z j bar plus 3x plus twice y plus z k bar. Okay. So if you want to find the curl of this one, so curl of a bar. So by definition we have to write this. Okay. So this is what is I bar, j bar, k bar. So dou by dou x, dou by dou y, dou by dou z. So first component is what? X plus y minus z, twice x minus y plus 3z, 3x plus twice y plus z. Okay. So then, okay. So write the first component. First component you have to drop this. So dou by dou of this one is 2. Dou by minus dou by dou z of this is 3. So this is 3 I bar minus, you have to drop this. To find second component you have to drop this. So dou by dou x of this is 3. Okay. Dou by dou z of this is what? Minus of minus 1. You have to take the care of the minus sign. Okay. So j bar plus, then you have to drop this. Okay. So dou by dou x of this is 2 minus dou by dou of this is 1 is k bar. Okay. So this is what? Minus I bar minus 4j bar minus 4j bar plus k bar. Okay. This is your curl of this. So while solving the problems from so if you want to choose a correct option, if f bar is given, then curl of f bar. So what I have to do? So I have to check all the options. If the first component, that means what? This twice I bar, this twice I bar, this twice I bar. Everywhere this is twice I bar. Option is suppose twice I bar. Suppose the second component is what? 3j bar. So plus 3j bar, plus 3j bar, plus 3j bar. Okay. So that means all the first component in the options, all the first component and second components are same. Only third component is different. Okay. So that means what here? What we have to write? Dou by dou x, dou by dou y, dou by dou z. Okay. So first component is what? X plus y minus z. So twice x minus y plus 3z. And third component is what? Twice y plus z. So what here? Only the third component is different. Okay. So third component is not same. All the first and second components are same in the all options. We need to find only the third component. For third component you have to drop this. You have to drop it. Just dou by dou x is what? This is 2. Minus dou by dou y is what? Minus 1. So this is what then? Minus 1. This is 1 then. So where is this plus k bar? So where is the plus k bar? This is the plus k bar. So this your first option is correct. If the first component is not same, in all the options, then find the first component only. For first component you have to drop this. Okay. Then dou by dou of this one is what? 2. Right? And dou by dou z of this one is what? This is what? Your third component is what? Z. Okay. This is z. Oh, second 3z. This is what? 3z. Okay. So dou by dou of this is what? Minus 1, minus of minus 1. You have to take the care of that one. Okay. So this is what? 3. So there may be the option for 1 also. So you have to take the care of this one, because this is minus and this derivative minus become plus. So 3. Okay. So just you have to do this one for competitive exam or for online exam. So do like this. Okay. So don't write all this is I bar, j bar and all those things. Okay. If you want only the first component, just write this only. Dou by dou y, dou by dou z. If you want first component, just write these two components only. Just take the differentiation with respect to y and differentiation with respect to z. Do the subtraction. You will get the first component and check which is your first component. In which option your first component is that. Okay. So that will be the correct option. Okay. In this way you can find the curl of this one. So no need to, while solving the problems from competitive exam or MCQ, don't find all the components. Okay. So take the decision from the option. If your first and third components are same, if your first and third component, you have to find only the second component. Just you have to write dou by dou x and dou by dou z. You have to find the second. So this is the first component. This is the third component of the F bar. Just find dou by dou x of this one, dou by dou z. So you will get the second component. Okay. So if you want the third component, just write this is dou by dou y. First component, second component. Find derivative of this, derivative of this. Okay. So this is dou by dou z. This is third component. If you want only the first component, do only this. Just write only this. Okay. Don't write the first component dou by dou x on this. Okay. So this will be your first component. First component will be first component we get with the help of only the second component and the third component. Okay. For the curl of the vector. Okay. Now we will define divergence of a vector also, and then we will see the properties of the divergence and curl of the vector. Suppose this is what F bar is equal to m I bar plus n j bar plus n k bar plus m n p, suppose. Okay. So where m and p are the functions of x, y, z. Okay. So that divergence of F bar, divergence of a vector, gradient of the scalar point function. Okay. So symbol is same for all this. Okay. So this is F bar. Okay. Then this is then dot F bar. The dot should be there. If dot is not there, it will become meaningless. Then it will be the meaningless. Okay. So this is what then dou m by dou x plus dou n by dou y plus dou p by dou z. It is a scalar quantity because dot product of two vector is a scalar quantity. Note that if a bar and b bar are the vectors, a bar and b bar are the vectors. If a bar dot b bar is 0, 0, then a bar and b bar are perpendicular. And this a bar cross b bar is a vector which is perpendicular to both a bar and b bar. So a bar cross b bar is nothing but a perpendicular vector to both a bar and b bar. And a bar and b bar are perpendicular, then a bar dot b bar is 0, not 0 bar. Okay, this is not 0 bar because dot product of the two vector is not vector. Dot product of two vector is a scalar quantity. Okay. Now suppose your f of x, y, z. Suppose your f bar is equal to x square y I bar plus 2y cube z j bar plus 3z k bar. So for divergence, so we have to find all the here. So divergence of f bar. So this is what del dot f bar is nothing but what dou by dou x of the first component. Dou by dou x of the first component plus dou by dou y of the second component plus dou by dou z of the third component. You have to find all those things. Okay. So this is what then twice xy plus 6y square z plus 3. Okay. So this is your divergence. Okay. Divergence is a scalar quantity. Okay. So now we see the properties of the curl and divergence now. Okay. So for curl, okay. So f bar is irrotational vector field if and only f bar is conservative vector field if and only del cross f bar is 0 vector, that is curl of f bar is 0 bar. Note that 0 bar, not 0. Okay. So remember that. If and only there exists a scalar function, scalar potential function phi such that f bar is equal to del phi, or you may say this is small f, so then this will be the small f. Okay. So remember this. Okay. So this is the first point. Then second point is what? The curl of grad phi. because gradient of phi is a scalar quantity. This is what? 0 bar. This is 0 bar. Okay. Okay. So now curl of k f bar. K is a constant. K is a scalar. Okay. So this is what? K curl f bar. K is a scalar. Scalar. Okay. And the next rule is also very important. Curl of f bar plus r minus g bar. This is same as curl f bar plus or minus curl g bar. Curl g bar. Okay. Now curl f bar. F bar. That means f is the scalar function. This is the function, and this k is the what here? Scalar. So if k is a function, then this is what? F curl f bar. Now this is f bar. Okay. This is f bar. Plus now curl means delta. Okay. So that is what actually this is the what? Nebula. This is nebula f bar. Okay. Cross now. This is what? Cross. Okay. So that this will write in it. Okay, no problem. So this is equal to curl f bar. So this is what then you have to take the curl of curl. So curl means what? Nebula. Nebula of f means this is the grad of this. Okay. So grad f dot f bar. Dot f bar or yes, this is dot f cross. This is cross f bar. This is cross f bar. Okay. So this is symbolically this is nothing but the cross f bar. Okay. So take cross f bar. Okay. So these are the properties for curl. Okay. Okay, now we'll do the property for divergence now. Divergence, okay. So property for divergence, it is only the solenoidal field. Okay, so f bar is solenoidal vector field. If divergence of f bar is equal to just 0, so that is what nebula dot f bar dot product. This is just 0, not a 0 bar. Option may be 0 bar also there. Okay, 0 bar. This option may be there. Okay, so note that divergence of a vector is a scalar quantity. So if divergence is there, you have to take the scalar quantity. Okay, so this is one note. You should know that. Okay, so which of the following field is a solenoidal? Which of the following field is solenoidal? Just find the divergence of each of the vector field. So which gives 0? So that will be your this. Okay, so remember this. Okay, now we see the properties of the divergence now. So second, divergence of curl f bar is 0. Means what? So this is the one. We'll write it symbolically. Okay, so nebula dot this cross f bar. Okay, this cross f bar. This is just again the scalar triple product. Okay, third one, divergence of k f bar is k. Divergence of f bar, k is scalar, not a scalar function. Okay, so this 4, divergence of f bar, where f is a scalar function. It is a scalar function. Okay, so divergence of f is f divergence of f bar plus, so this is the gradient now. gradient of f dot f bar. So f is a scalar function. F is a scalar function. Okay. Next, divergence of f bar plus or minus g bar is divergence of f bar plus or minus divergence of g bar. Okay. So these are the property of this. Just remember this. And divergence of f bar cross g bar. Divergence of f bar cross g bar is g bar dot. This is very important. Curl f bar minus f bar dot curl g bar. Okay. Remember this. Remember this, there is the curl. Divergence. This is the curl. This is the curl. Okay. There is no divergence. Okay. So these are the properties of the curl and divergence. So that you should remember this. Okay. Okay. So in this chapter we have seen the curl, divergence, Stokes theorems also we have seen. Okay. So just we will define the Stokes theorem now. We'll take the Stokes theorem. So in this chapter also, these properties of the divergence for practice is what? You have to find a curl, you have to check whether the field is irrotational or field is conservative. Just you have to find the curl of the vector. Okay. If the curl of vector is 0 bar, then your whatever the scalar field is there, that will be your irrotational vector field, all conservative vector field. Okay. So Stokes theorem. This is very important now. Stokes theorem. Okay. So we state the Stokes theorem. Let S be a piecewise smooth oriented surface having a piecewise smooth boundary curve C. Let f bar is equal to m I bar plus n g bar plus p k bar. So you may take this is f1 I bar, f2 j bar, f3 k bar, doesn't matter. P a vector field whose components have this part is very important. Component have continuous first partial derivatives on an open region containing S, then the circulation of f bar around C in the direction of counterclockwise with respect to the surface unit normal vector n bar is, that means what? Circulation of f bar dot dr bar, circulation over C is the surface integral. S is equal to del cross, that means this is the curl of f bar. Okay, dot n bar d sigma or ds, doesn't matter for this one. Okay, that means this is what line integral to the surface area. Okay, so we'll write a note now. We'll write a note. Okay, Stokes theorem. Convert line integral to surface integral, and vice versa, surface integral to line integral. Okay, that means Stokes theorem is the relation between the line integral and the Stokes theorem. Okay, so that means what? So relation between the line integral and that means the Stokes theorem gives the relation between the line integral and the surface integral. Okay, this gives the relation between. Okay, so now this is one note. Okay, second. Okay, so this convert line integral, that means what the Stokes theorem is the relation between line integral and surface integral. Okay, so that means what the line integral and surface integral, relation between line integral and surface integral gives Stokes theorem. Okay, so gives the Stokes theorem. Okay, that means Stokes theorem gives the relation between line theorem and surface integral. Okay, so Green's theorem, we have seen the Green's theorem. Green's theorem is a special case of Stokes theorem, because in Green's theorem also you are converting the line integral into double integral. Okay, so that means the Green's theorem is also is a special case for the Stokes theorem. So vector field Fr is conservative in simply connected open region D in R3, that is in space, then integral over C Fr dot dr bar is equal to 0. Okay, other conservative means e-rotational also. They will apply the e-rotational. That means vector field Fr is e-rotational is simply connected region, then the line integral is 0. This is the Stokes theorem also. By Stokes theorem, because what this is the field is conservative, that means curl is a 0. So this is what double surface integral will be what? So curl is 0, that means it is 0. Okay. So Fr is conservative implies that Fr is equal to del f. That means del f is a scalar function f such that Fr is equal to del f. Okay. So this is implies, this is if and only curl of Fr is equal to 0. We are not repeating this, just we have explained this. Okay. So this is also this is by Stokes theorem, line integral is 0. If field is conservative, then the circulation, this is the circulation, Fr the dr bar is 0. So if Fr is a conservative vector field or e-rotational vector space, e-rotational vector field. Okay. So now after that we have seen the divergence theorem. Okay, so read all the conditions are divergence theorem. Okay, let a bar. Okay, so we write the divergence theorem. Divergence theorem in 3 dimensions. Okay, in 3 dimensions. So it is also called Gauss divergence theorem. This is also called Gauss divergence theorem. Okay, so we'll state the theorem. Okay, so just we will state the theorem. Okay, let F bar be a vector field whose components are whose components are, whose components have, not are, whose components have, whose components have continuous partial derivatives, partial derivatives, or continuous partial derivatives, continuous first partial derivative, okay, first partial derivative, first order partial derivatives, and let S be, and let S be a piecewise smooth oriented surface, closed surface. So closed surface is very important here, closed surface. Then double integral over S f bar dot n bar d sigma or ds, triple integral over d divergence of f bar dv. So this is also same as double integral over S f bar dot n bar ds. Okay, instead of the sigma, the ds will be there, no problem for this one. So that means what here? Note, divergence theorem convert surface integral into, this is surface integral, into volume integral, okay. So or volume integral into the surface integral. So that is for divergence theorem, it is double integral to triple integral. Green's theorem and the Stokes theorem, they convert the line integral into double integral or double integral into the line integral. Okay, so remember that. Next we write a note, for any closed surface S, for any closed surface S, double integral over S curl f bar dot n bar ds is always 0, where V is the value of the region enclosed by the surface S. See, this is surface, this is the curl of f bar. So curl, this is f bar dot n bar. See, f bar n bar dot this is, okay. So this is the triple integral divergence of f bar. So divergence of curl of f bar is 0. So therefore this is 0. Note that. Divergence of f bar. This is what? Curl. This is surface integral of curl of f bar. This is the surface integral curl of f bar. And this is what? Triple integral of the divergence of curl of f bar. But divergence of curl of f bar is always 0. So this is 0 therefore. Okay. So note that this. Okay. If R bar is equal to, we take a simple problem, one or two simple problems. So if R bar is equal to xi bar plus yj bar plus zk bar, S is closed, F is closed surface, and V is the value enclosed by the surface S, then by divergence theorem, then by divergence theorem, then by divergence theorem, double integral over S r bar, this is r bar, a bar is what? R bar dot n bar ds is equal to triple integral over v, triple integral over v. You want to calculate this, you want to calculate this, but this is I bar dot n bar ds is nothing but what? Divergence of r bar into dv, divergence of r bar into dv, just okay. So what is the divergence of r bar? So this is what? Triple integral over v divergence, okay. Dou by dou x of this is 1 plus dou by dou of the second component is 1 plus dou by dou z of the third component is 1, okay. So don't do this, but we have to solve this problem within 1 or 2 minutes, okay, 1 or 2 minutes. So therefore what? So do fastly this, just say you know the divergence means what? Dou by dou x of the first component plus dou by dou y of the second component plus dou by dou z of the third component. So this is 1 plus 1, this is dv, right? So this is what 3, then this is what? V dv, right? So that is what? 3 into v is the volume of the what is this? V is the volume of the enclosed by this. So this is 3v. So this is r bar. So this is very simple actually. This is very simple. Okay. So if this is what? Suppose like this. Suppose this is x I bar plus j bar plus k bar is given to you. So divergence is very easily you can calculate. So this is what? This is 0. This is 0. This is 0. This is 0. So this is 1. This is 1. So simply what? This will be v then. This answer is what? V. So no need actually this. Only what here? We have provided a bar. Okay? A bar is provided such way that what? Divergence of a bar is a constant. We have provided a bar such way that what? Divergence is a constant. Okay? So then whatever the divergence into V. Divergence into V. So this is what actually? This is nothing but what? Divergence of R bar into V. Into V what? Both are the scalar. Into V. Actually. This. Because the divergence of r bar is constant. Okay, this is the very important thing here. So for double integral you can convert into the triple integral. Okay, one more problem from the exercise is there. One more problem from the exercise is there. That is the shown at problem is there. So this is here. Line integral over C. Line integral over C. Y plus z I bar. Z plus x j bar. Plus x plus y k bar. X plus y k bar. Dot dr bar. Dot dr bar. What is this? Okay. So this is f bar dot dr bar dot. So line integral is same as you can convert into double integral. Okay. So that is what? Double integral curl of f bar. Curl of f bar dot ds bar. Okay. Curl of f bar dot. Curl of f bar dot. Okay. ds bar doesn't matter. This n bar ds. Okay. N bar ds or ds bar doesn't matter. This. Okay. So now curl of f bar. So this is what? Curl of f bar. So what? Dou by dou x, dou by dou y, dou by dou z. Just we find curl of this. Y plus z, z plus x plus y. Okay. So for this is very difficult because what? It is not given, anything is not given to you. Okay. So it must be 0. If the curl is 0, then problem will be the over now. Okay. Always write the value is what? 0. Always write such type of the problem is there. Always write the value 0. If a curve is not given. Okay, C is not given to you. C is not provided to you. Okay, so you have to apply the Stokes theorem because the line integral is converted into double integral by Stokes theorem. Okay, so we will apply the Stokes theorem. So this is what is for first component. See, this is what 1. This is what minus 1. Okay, so this is 0. Your first component is 0. For second component, just this is what 1 and this is 1. Again 1 minus 1. Your second component is also 0. For third component, derivative of this is 1 and minus 1 again. Okay, your third component is also 0. So this is what then 0. This is 0. So very simple now. Okay, so such type of the simple problems will be asked. Such type of the simple problems will be asked. Okay, so that what? So this is what your curl will be 0. Okay, so just find the curl of this one. Okay, so I hope that you understand this one. Okay, so you have to generalize this. You have to generalize all the problems. Okay, so remember the statement of the Stokes theorem statement of this, some properties of the divergence, properties of the curl of this one. So find out the curl of the vector with the simplest way. So I told you that how to curl of the vector. So if you want to choose from the option, just look at the components of this one. If all components are different, just find only the first component. For first component, you have to write this only what dou by dou y dou by dou z here first component. Okay, so just with the help of the first component, you can judge your option. Okay, so I hope that you can do all these things. Just generalize this. Okay, so try to solve the simple problems on it. Okay, so now we stop here. Thank you.